In this video, we're going to look at terminal input, meaning to say input that's performed in the terminal window during the execution of the program. So I've started a program here. Suppose this program is intended to calculate the, let's say, for the purposes of the example, volume of a cylinder, where the formula is volume equals pi times the radius squared times the height. Okay. So pi r squared height. Okay. So we need to know the radius of the cylinder and the height. Right. The idea is something like this. We have a cylinder. And radius of the cylinder is that. Height of the cylinder is that. If we know those two things, we can compute how much stuff, right, we can put into this container. So we can do this by specifying height and the radius as variables. We can say double radius, let's say it's 1.5, oops, equals 1.5, there we go. And double height is 5. And we calculate volume, set up the declare the variable in one statement, and then assign it in another. And I'll say math.pi. All right, so I don't have to look up the value of pi. It's built in and made available via this symbol, math.pi times radius times radius times height. And then we want to display the result. And see how that looks. There we go. No errors. That's good. No news is good news in the case of compiling. And to execute, we say Java, and then just the first part of the name. Okay, and there it is. And that's the value we'd expect from these numbers. All right, suppose now we want to calculate the volume of a different cylinder. Maybe it's got a bigger radius, right? And it's, instead of 1.5 units, whatever our units are, it's 2. Okay, so I have to change the value that's given in to this value. And then because I made a change in the program, I have to recompile. Oh, okay, and it's a different number. All right, so it's just making it a half a unit bigger radius gives us almost twice the capacity. It's interesting. All right, if I make a shorter cylinder, rerun, I have this exact same value both times. This is a very, very easy mistake to make. Notice I ran the program again. I executed the program again without recompiling. Right? I made a change. I changed height to 4, but I didn't recompile. So the system doesn't know that I've made a change. It's running the previous version where height was 5. So that's why the answer still comes out right. So when you see results you don't expect, it's one thing you want to make sure of is that you've recompiled all your changes and that your program is up to date. Right. Okay, now sure. If you make the cylinder smaller, you'd expect to get a number. All right, now, the problem is that this program is not very flexible. Right? I have to modify a statement and then recompile to look at volumes of different cylinders. There's a better way. And that is to have the program stop and ask for these numbers while it's executing. So we do that with a scanner object. And to set up for this, I have to bring in a library. All right, and that's done like this: import java.util.star. All right, so what this statement is doing is telling the runtime system that I'm going to use a library of routines, all right, to perform certain common tasks. Right? And it's optional because plainly we've been writing programs up to now without doing this, so it's not necessary in every program. So it's going to be used in most programs, but that's why you have to import it. Right, so to set up for performing input, I have to declare a library object called a scanner. All right, and that goes like this. So you use the word scanner, it's capital S, 2 N's, spelled just like that, and then you make up a name for your scanner. You can call it anything you want. I will often call mine keyboard, right, to remind me that this is where the input is coming from. Right, then you create it like this. .in. Right, so that creates. We'll put this comment above. So, so this statement does exactly what I've got there in the comment. It creates a scanner object to perform input with. No input is performed yet. All right, so just creating the scanner object doesn't perform any input. If I want to perform input, you have to change what's going on here. I'm not going to assign a fixed value here anymore. I'm going to say, keyboard, give me the next double. And keyboard, give me now another next double. And it's important that you use the same spelling for whatever you named your scanner. Right? In place, then follow it with a dot, and then next double if you're trying to read a double. Be next int if you're trying to read an int. All right, now let's look at what happens here. So I made a change in my program, so I'm going to recompile and run it. And it seems like nothing is happening. Well, in fact, as we've seen before, these are assignment statements right here. This is an assignment statement, right? Because one value is being assigned to another. The flow of an assignment statement is right to left. Right? The right-hand side executes first, and then whatever value the right-hand side evaluates to is stored in the left-hand side. All right, so what's going on? What's going on here? How come nothing's happening? Well, it's precisely because this right-hand side is executing. Right? It's waiting for me to type in some number. Right, so let's say 1.5. All right, so now we can trust that the 1.5 is stored in this variable, but still nothing's happening. Well, it doesn't look like anything's happening. But what is happening is that the system is blocked, is the technical term. It's blocked on this line, waiting for me to type something. I'll type 5. Okay, so once I provide the necessary input here by typing some numbers and pressing return, the statement completes and execution continues. The calculation is made and we see the result. So now, this feature that execution stops and waits can be sort of confusing. So we always want to precede an input request with some kind of message that says what what the user is supposed to type as a reminder of what's going on. So I'm going to use system out.print All right, so I'll put a print statement that will come out right before execution pauses. Now to remind me what I'm supposed to do and what order things are supposed to go. So if I give these numbers in the wrong order, I'm not going to get the right answer. So let's recompile, because I made changes. And now run it. Enter the radius. So now the program is kind of like telling me what to do. So I put 1.5 and 5. Separate those numbers so the system knows I'm giving two values. It happens. Now I can run the program again without recompiling and give some other numbers. Right? The program becomes much more flexible this way. Because it can be used with any inputs.